Hi class, today is going to be all about factoring polynomials to solve. We're going to actually break this section up into a couple different parts just because there's a lot of information. And so this video is going to be focused on two-term polynomials. Now for all of this, for both sections, you want to make sure you always look for the greatest common factor first. That's going to usually make solving it and simplifying it a lot easier. So that would always be my step one. And then you have to look at how many terms the polynomial has. So for two-term polynomials, examples of that might be something like x squared plus 6x, or maybe something like 2y squared minus 18. Okay, so something along those lines where there's only two separate terms with addition or subtraction in between them. There are three things you want to look for first. The first thing you want to look for pattern-wise is if it's difference of squares. So what that means is that the first term and the second term can both be written as something to the second power. Okay? If they are difference of squares, then you would use this rule where it's factored into a plus b and a minus b. Now that has to be a subtraction in between them. It cannot be a plus, so that's important. The next two are both when you're having cube roots, so there's sum of cubes and difference of cubes, and this is when you can take the first and last term and write them as something to the third power. And if you can do that either with the plus or the minus in between, then you have these two formulas here that you would have to fill out. So you want to make sure you write these in your notes, and then we're going to go ahead and talk about how to use these in a couple different examples. Let's jump into our first examples. Remember, always step one, you want to look for the greatest common factor. So in example one, we have 7x squared minus 14x. Here, our greatest common factor would be a 7 and an x because that's what we can take out of both. So if I take out a 7 and I take out an x out of both, in the first term I'm left with an x, and in the second term I'm left with a 2. And so I can't break this down any further because my degree is 1, so this would be my factored form. Okay, so that's all you can do on this one, greatest common factor, and then be done. The next example, you could always look for greatest common factor again. So I notice here that both of my terms can take a 4 out. So if I take out a 4, I'm left with f squared minus 16, and then we have the unique case of two terms that can be written as perfect squares, and that's because f is to the second power and 16 can be written as 4 to the second power. So that's the way to check. So when we use difference of squares, the rule is that you factor it a plus b and a minus b. So we're going to have 4 times f plus 4 and then f minus 4. So this was my a value, this was my b value, and then we'd be done. Now the next example, number 3, is m to the 4th minus 1. And this one looks a little different because it's still subtraction like the others. However, we notice that our exponent is not a 2. So at first you might think that this is not difference of squares. However, we know that 4 can be rewritten as 2 to the second power. So because we can do that, we can use difference of squares. So what I'm going to go ahead and do is rewrite this. So m to the 4th would be the same as m squared to the second power, and then 1 can be rewritten as 1 squared. So here's my a term and here's my b term. So now we just need to plug into our formula. So we know that this would become m squared plus 1 because it's always a plus b, and then m squared minus 1 because it's a minus b. Just like the other examples, the only difference is that our exponents are higher. Now the one major difference here is that when you look at these factors, you always want to check and see if you can break them down any further. So in this example, we have another subtraction of squares. So because this is another difference of squares, we actually need to break this one down again. So we can rewrite m squared as m to the second, and then again 1 to the second. So I'm going to break this one down into m plus 1 and m minus 1 because that was our a here and our b here. So this one had two parts of factoring, the original factoring and then breaking that one down even further. Now the one I left in green here cannot be broken down even though it's got a perfect square because it's a plus sign. So the rule only works when it's a subtraction sign, and there would be our final answer. Now the last example, if you notice, is an exponent or a degree of 3. So we can't rewrite 3 to any second power. That means that we're going to be having to look at our sum or difference of cubes. So if you remember from your formula, we can use plus or minus in this rule. Notice here that we have a minus, so our formula says we're going to have a minus b, and then a squared plus ab, and then plus b squared. So what we have to do is figure out what a and b are, but the other thing I would encourage you to do is still look for a greatest common factor. Unfortunately, 8 and 125 have no common factors, so we're going to go ahead and just jump right into our factoring steps. So we know it's going to be a subtraction sign at first, but we have to figure out what a and b are. So the easiest way to do that is to rewrite it as cube roots. So 8 can be rewritten as 2 to the third, and n to the third can be rewritten with just an n there, and then to the power of 3. And then the 125 can be rewritten as 5 to the third. So you have to think in powers of 3 this time. So that means our a value is going to be 2n, and our b value will be 5. So once we know what a and b are, then we literally just fill into our formula. So filling that in, my a value is 2n, and my b value is 5, so minus 5. Then we continue filling in the rest of the formula. A squared, so I'm going to have 2n, if you square it, becomes 4n squared. So I'm going to put 4n squared there. So that's important. You make sure you square all of it. Then a times b, so 2n times 5 is 10n. So I'm going to have plus 10n. And then lastly, b squared, that's 5 to the second, which is 25. So plus 25. And then you'd be done. Usually when you've used the sum or difference of cubes, it's no longer going to be factorable after that, so this would be your final answer. And the process would be the same even if it was a plus sign in between. Obviously just your signs would change. So make sure you know what your a and b terms are, and then fill into your formulas. That's it for the 2-term ones. Next we're going to be talking about 3 and 4-term polynomials.